The deep sea is a realm of extremes. In this series, we've examined how creatures have adapted to survive in the daunting, cold, and dark depths. We've explored ecosystems that exist in this unforgiving environment and seen how life forms cling to any available energy source, from superheated water vents to the remains of sunken whales. Now we'll dive even deeper to uncover a place where life is pushed to its absolute limits. At the bottom of the Pacific Ocean, the seabed opens into a vast abyss filled with peculiarities. Faceless fish, sprawling fields of bacteria, and giants that seem to hail from another world. Let's delve into the concealed wonders of the Mariana Trench. The Mariana Trench is a crescent-shaped scar on the Pacific Ocean floor, stretching 2,150 km long and 69 km wide, plunging into a pitch-black void. It hosts Earth's deepest known point, the Challenger Deep, which lies 11,033 nori, 36,200 honor beneath the waves. This trench is but one segment of a global network of deep scars formed by subduction, a process where, in this case, the Pacific Plate's western edge was pushed beneath the smaller Mariana Plate to the west, creating this profound chasm. Volcanic activity subsequently rose through nearby volcanoes, forming the Mariana Islands. At its deepest, the trench descends into a little-explored oceanic zone called the Hadal Zone, after Hades, the Greek mythological underworld. This name perfectly suits a place where conditions of utter darkness, acidic and freezing waters, scant food and immense pressure challenge survival relentlessly. Historically, the Hadal Zone was believed to be lifeless, an impenetrable frontier beyond human reach. However, this notion began to change with explorations undertaken in the 19th century. In 1875, the HMS Challenger's crew unexpectedly discovered the trench's depth when their weighted line fell short. This finding catalyzed subsequent daring explorations. In 1960, two men, Jacques Picard and Navy Lieutenant Don Walsh, set out to reach the bottom using the cramped submersible Trieste. During their descent, the intense water pressure caused the viewing window to crack, limiting their exploration of the ocean floor to just 20 minutes. Yet in that brief time, they encountered life, pale shrimp and flounder-like fish, as Picard vividly recounted in his voyage narrative. In 2012, James Cameron followed the Trieste's path on board the Deep-Sea Challenger. His descent, 10,912 m, 35,800 ft, deep revealed microbial mats and bizarre filamentous microorganisms thriving in a sunless existence, a testament to chemosynthesis, the deep-sea equivalent of photosynthesis, that supports complex life forms in absence of sunlight. This awe-inspiring footage, captured in 1996 by the unmanned Japanese submersible Kaiko at a depth of 10,997, marked the deepest dive at the time. Kaiko aimed to sample bacteria seen by Picard and Walsh 40 years prior, confirming many barophilic bacterial species flourished under extreme pressures, a challenge to traditional views that life thrives only in moderate settings. In 1998, during its return to Challenger Deep, Kaiko discovered more intricate life forms like the gigantic amphipod species Hirondelia gigas. This discovery presented a mystery. The extreme pressure dissolved calcium carbonate shells like those of most amphipods and marine creatures at such depths. Yet these creatures existed beyond 5,000 therm, 16,400 ft, with intact shells due to aluminum armor derived from seafloor mud, indicating a unique adaptation. Recent remote submersible observations have uncovered more peculiarities of the Mariana Trench, including the holothurian sea cucumbers like the sea pig, equipped with tentacles for sifting food from mud. Some scientists suggest that Picard's fish sighting might have actually been a sea cucumber, given the hostile environment likely dissolving vertebrate bones. Snailfish, discovered in 2014, are among the deepest known fish species, thriving at 8,000 m, 26,200 ft, 2 km above the Challenger Deep. Other species found in the trench include xenoagavorians, gigantic single-cell organisms, predatory sea squirts, and bioluminescent hatchetfish that disguise themselves with light. Even though countless expeditions have gathered footage, we've merely touched the surface of the Mariana Trench's hidden realities. New species likely await discovery, potentially offering insights into life's survival under such extremes. Researching these microorganisms could drive breakthroughs in biomedicine and biotechnology and illuminate life's origins on Earth. Yet human encroachment has already tainted these profound depths with plastic. It's vital to preserve these unexplored mysteries before they disappear, unappreciated, another victim of our ignorance.